Today, we will discuss the product rule in differentiation with the help of animation. Here, ddx of u into v, two functions, is equal to v times ddx of u plus u times ddx of v. This is the product rule. So product rule is differentiate one function at a time. This one function we are differentiating, multiplying by the other function, this, while keeping it unchanged. And such terms, the second term also, such two terms we will be adding. So adding the resulting terms. One thing here to be noted, like we are differentiating here first term first and second term next. So since plus sign is here, we can differentiate second function first and then first function second. The result will be same since plus sign is here. Now one more thing is to be noted, that this is the only formula we have to remember for product rule, nothing else. Rest whatever we have done in our previous video, if you have not gone through those, please go through those videos or at least learn all those formulas which will be frequently used in product rule, quotient rule and all chain rule and implicit function, etc. So please enlist all those formulas first and then proceed. Now we'll solve few examples on product rule. Find ddx of the following expressions. So please pause and try these problems yourself, else view the solution below. Solution to problem number 1. Here ddx of x to the power 4 into e to the power 7x is equal to e to the power 7x into ddx of x to the power 4 plus x to the power 4 into ddx of e to the power 7x. Differentiation of one at a time. Then ddx of x to the power 4 as usual 4x to the power 4 minus 1. ddx of e to the power 7x is 7 e to the power 7x. What I have already mentioned, that we'll be using those formulas only, except this rule, differentiation of one at a time and plus sign in between. The final result is 4x cube from here, e to the power 7x, then 7x to the power 4 e to the power 7. This is the final solution answer. Now second sum. Here we are just considering different combinations, like here we are considering e to the power 5x and log x as the two functions, product of two functions. So same rule will be applied, log x into ddx of e to the power 5x plus e to the power 5x into ddx of log x. So ddx of e to the power 5x is this, ddx of log x is 1 by x. So you have to remember all those formulas. Now here the final answer is this. Now solution to the third sum. Here again we are considering another combination, algebraic versus logarithmic function. So we are keeping log 4x outside, differentiating x to the power 6, and here keeping x to the power 6 outside and differentiating log 4x. Plus, remember, plus in between. Sign is very important. Now log 4x into 6 into 6, x to the power 6 minus 1 plus x to the power 6 1 by 4x, differentiation of log 4x into 4 times. So 4 and 4 cancels out. So final result is here 6 x to the power 5 log 4x plus here 4 cancels out, and this x and x to the power 6 cancels out, giving x to the power 5 as final result. Now the last and fourth sum, ddx of 7 e to the power minus 3x into x square. Here is one new point, 7 is also included, constant. So since it is constant, before proceeding further, we'll first keep it outside, as shown here. 7 is outside. Now we are applying differentiation on these two parts without involving 7 at all in this differentiation process. So it will be simple. Now here we are differentiating this first, keeping this outside. Again differentiating x square here, keeping this outside. So here only the application of formula. Final result is just explaining how we have reached it. Minus 3 into 7 is minus 21. We are keeping the color for simple coefficient constant as brown, and this blue color for x to the power and pink color for e to the power x, coefficient of x. Again here 7 into 2, 14, x to the power 2 minus 1 is x, e to the power minus 3x. So this is the final result.